Welcome to BodMaths. This is a new maths channel covering multiple topics across all exam boards from GCSEs to A-levels to Key Stage 3s. And I want you to get the most out of this channel and the most out of your time watching these videos. So comment down below any topic requests and any questions that you want answered. And make sure to head over to my Instagram at BodMaths_ for some extra content. So without further ado, let's get stuck into these equations. Today's topic is the beautiful partial fractions. And what do I mean by partial fractions? A single fraction with distinct linear factors in the denominator can be split into separate fractions with linear denominators. This action is called splitting it into partial fractions. And there are two methods to find the constants. One is by substitution and the other is by equating coefficients. In today's video, we're going to be working with both of those so y'all can see how you do it. Before getting into the questions, I'm going to show you what partial fractions actually look like. So I have some examples here. Both examples number 1 and 2 show you the fraction with distinct linear factors in the denominator, and these get split into the partial fractions, which you'll see on the right hand side. And they can be split in this way because when you add the fractions on the right hand side, those partial fractions together, you will get the left hand side expression. Basically, our role in this is to work out what those constants A, B and C are going to be. I know you're probably wondering, what about example number 3? Example number 3 cannot be split into partial fractions because the linear factor in the denominator is repeated. So we have x minus 1 squared. Because we have this linear factor repeated, it can't work that way. Partial fractions only work when the linear factors in the denominator are different, which is why we can do example number 1 and 2. And as you've witnessed from the example in the middle, partial fractions can be split into more than 2, and this is just dependent on how many linear factors are in the denominator. So if there's 3, like in example 2, then you'll end up with 3 partial fractions. Okay, so now we've gone through the basics, we can get started on the questions. Question number 1, show that minus 2x minus 5 divided by 4 plus x times 2 minus x can be written in the form a over 4 plus x plus b over 2 minus x, where a and b are constants to be found. Question 1 is actually an exam question worth 3 marks. This question wants us to find out what a and b are, and for the sake of showing you how to substitute and how to equate the coefficients, I'm going to show you how to use each of those methods to get the answer to this question. Before we dive into each of those methods, let's first bring up the first line of answering this question, which is always going to be the same in any partial fraction question. And this is where we have the expression equating to the partial fraction. In this question, we only have 2 linear factors, hence why we're going to end up with 2 partial fractions. The first step after this will be to add those partial fractions together so that we end up with the same denominator as that first expression. So this is just our simple adding fractions method, and if you do want a video on adding fractions, I can make that for you, so let me know in the comments down below. But once we add those fractions together, we're going to end up with a times 2 minus x plus b times 4 plus x all over 4 plus x times 2 minus x. So all over that same denominator. Now that we've done this, we're ready to get into our methods and find out what those a and b constants are. And in both methods, we always start off doing the same thing, which is equating the numerators to each other. So we have the minus 2x minus 5 equal to the a times 2 minus x plus b times 4 plus x. So it's always going to equal that top line. The reason why we can do this is because the denominator is the same now that we added the partial fraction together. The first method we're going to do is substitution. When we substitute, we try and make one of those brackets next to the a and next to the b equal to 0. By equaling to 0, we eliminate one of those constants because once we times that bracket by the constant, we just get 0. So for this question, we're going to have to find 2 minus x equals 0 and 4 plus x equals 0. First, we'll look at 2 minus x. 2 minus 2 is going to equal to 0, so x here is going to be equal to 2. And all we do now is substitute x equals 2 back into that expression, which becomes this line here. Now we can expand and simplify to eventually get minus 9 equals 6b. We now end up with minus 9 over 6, which simplifies to minus 3 over 2 equal to b, and that's the first constant we have found. Now that we've found b, we can go on to finding a. So as we've done x equals 2 from the bracket 2 minus x, we now need to find the x for when 4 plus x equals 0. So this x is going to be minus 4, as 4 plus minus 4 equals 0. With x here now being minus 4, All we have to do is substitute that back into that first line, and simplifying and expanding that, we eventually get 3 equals 6a. Switching that over to the other side, the same way we did when finding the constant b, we're going to get 3 over 6, which simplifies to 1 over 2, so a is equal to a half. And there we have it. We found both constants a and b through the method of substitution. And I told you that I was going to show you both methods, so stick around whilst we do this question again, but through the equating coefficients method. And this time around, what we're going to do is expand that right-hand side. So we'll get minus 2x minus 5 equals 2a minus ax plus 4b plus bx. And now we can take the coefficients. So what I mean by coefficients is the fact that you have the x coefficient and you find that on all sides of the expression. So you have minus 2x, and on the other side you've got minus ax and plus bx. So all those x's you'll group together, and you'll get minus 2 equals minus a plus b. And you do the same with minus 5. So that coefficient is going to be minus 5 equals 2a plus 4b. Working with these coefficients, our aim is to eliminate one of the constants through subtracting or adding these expressions to each other. On the right-hand side of these two expressions, we have minus a plus b, and then the other we've got 2a plus 4b. So in common, we can either times the first expression by 4 to work with the b's, or we can times the first expression by 2 to work with the a's. We've already got a subtraction of minus a in the first expression, and then we have a plus 2a in the second expression. So we've already got those two signs working against each other. And as multiplying by 2 is just a smaller multiplication, I personally would go for that option. So what we do here is times that first expression, everything in that expression, we times it by 2 in order for the a's to be the same, which means we can eliminate that constant. So we now have minus 4 equals minus 2a plus 2b. We're going to add that expression to the expression of minus 5 equals 2a plus 4b, because this will cancel out the a's. Adding these expressions together, we get minus 9 equals 6b. Rearranging that, we get minus 9 over 6, which equals minus 3 over 2, and that is our b. And that's the hard part of this method of equating coefficients out of the way. So now that we found our b, all we do is substitute that back into the expression. And I'm going to choose to put this back into the expression of minus 2 equals minus a plus b. So doing that, we end up with minus 2 equals minus a minus 3 over 2. And then guess what comes next? Rearranging. So we rearrange this and add our fractions together, and eventually we'll get 1 over 2 equals a. So a is a half. And we've just found our constants a and b through both of the methods, substitution and equating coefficients. Way to go, team! Quick top tip, when you're doing partial fractions in an exam, make sure you do write the values of the constants you found at the end of the question. And if they ask you to put it in the form of the partial fractions, then put it in the form of the partial fractions. You found a and b, so all you need to do is replace that in the partial fraction. They just want to know that you know what you've done, how you've done it, and what it means for the answer of the question. If that makes sense? I hope so. So this has been quite a big chunk to get through in one video. So what I'm going to do is put question 2 and question 3 into a second video and make that a part 2 of partial fractions, just so you can have a break from me talking. And if you're anything like me, you'll get distracted quite easily. So I don't want to make this video too long. Plus, this gives you the opportunity to go through any partial fractions questions and start working through that with the different methods that we've worked through in this video. And it also means that you could send me any questions, and I might even be able to incorporate them into the part 2. And if the maths ain't mathing, please comment down below any questions you may have, any topics that you want covered, and head over to my Instagram at BodMaths_ for some extra mathematical content. And check out my story for the countdown to the next video. So make sure to give this video a like if you found it helpful, subscribe and turn your notifications all the way on so you can be updated when the latest video hits. Thanks for watching, and I'll catch you in the next video.